Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Thabang Mongatane. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and the broadcast by Pagama Research and Development. Grade 12, as normal, we'll always remind you on how paper 1 is structured. Mechanics, paper 1 in both final exam and prelim. It will be mechanics, it will be 93 marks out of 150. Electricity and magnetism will be 33 marks. Sound, wave, and light will be 24 marks. You can see grade 12 where you need to focus so that you get your passing marks. When you're coming to weighting, we say mechanics is 62% and electricity and magnetism will be 22%. Wave, sound, and light will be 16%. The total of the paper 1 will be out of 150 marks, and then duration, it will take 3 hours. More, nothing less, nothing more. And then weighting will say our level 1 questions, which are remembering, it will be 25, and then level 2 questions will be 30%, and then level 3 question will be 40%, and then level 4, which is most difficult questions, will only take 5% of the paper. We're still continuing. We say we have in an exam, we have two sections, section A and section B. Section A is multiple choice questions, where you'll have 10 multiple choice questions, which each multiple choice question will be 2 marks. Then if you have 10 questions, that means the marks will be 20 marks. Then section B will be a structured or long questions. That's where we found the definitions, the stating of the laws, and the calculations. And then those questions, they will take 130 marks. The total of the paper, as we said before, is out of 150 marks. The duration is 3 hours. And the topic that we are doing today is what? Elasticity. The elasticity is what? Is about plus minus 25 marks in an exam, both prelim and final exam. Here we have a mind map for elasticity. This is a topic. This is where you need to focus when you're dealing with elasticity. Elasticity, then it will be breaking down into deforming force, restoring force, perfectly elastic body, and perfectly plastic body. And then under deforming force, we found stress and strain, and stress and strain will lead us to Hooke's law. Elasticity. We're going to start with the definitions of in elasticity. We have a number of definitions, but this is how we need to focus when you're looking at the definitions. We say the following definitions are very important. They must be mediated and be known by heart. That means grade 12s, it is very, very important that before you go to sleep every night, you must practice every day 2 or 3 definitions. 2 or 3 definitions every day, because those definitions are very, very important, and mediate them so that you know them by heart. Always follow the definition from the exam guideline, not the one from the textbook. We're using the definitions from exam guideline grade 12s because that is when we mark the prelim and the final exam. We are using definitions from the exam guideline. We don't use the definitions from what? The textbook. All the definitions are awarded 2 marks in the definition if the definition is correct. That means if you can define any term correctly, that means you'll get 2 marks. And then if the definition is not correct, 0 mark will be awarded. That means if you didn't, there is something wrong with your definition that you wrote down, you lose all the marks. We don't award 1 mark if the definition is half correct. We award 0. Is either you get 0 or you get 2 when coming to the definitions. It even says here, if some part of the definition is correct and some part is incorrect, 0 mark will be awarded. That means if one part of the definition is correct, we're not gonna focus on that. We ignore that correct part of the definition. Then we give you 0. That means it is very, very important, grade 12s, that you always, when you write down the definition, it must all correct. It must be correct. We say all the laws stated correctly will be awarded 2 marks. We have laws and we have definitions. The laws that we found in technical science, like Hooke's law, in elasticity we have a Hooke's law. If you define Hooke's law correctly, you will also give you what? 2 marks. And then if the law is stated incorrectly, then you will have what? 0 mark. We're not gonna get any mark out of that law. And then if part of the law also is correct and the other part is incorrect, that means we're gonna give you 0. We're gonna give you 0. We're not gonna even try to give you 1. No. It's 0 or 2 marks. Questions on laws and definition can be or will be asked in question 1 of the question paper in the multiple choice question. We're using laws, some laws and some definitions in question 1 as a multiple choice questions. That means you see how important it is. In order to get the multiple choice correct, you must know the law. You must know the law fully and understand them, grade 12s. You will be given the laws or definitions and asked to name the law or the definition. It's either, grade 12, we give you the law, the name of the law, or the definition. And we'll give you the law or the definition, then we ask you to do what? To define or to state that law. Or what we can do is what? And sometimes we do what? We give you the name of the law or the definition, then you need to do what? To define or to state the law. Or we do what? We give you the law and or the definition and we ask you to name that law. Like as we do in what? We can tell you that we can ask you to do what? To define Hooke's law or to state Hooke's law. Then, or we do what? We give you Hooke's law and we ask you to name it. That's how we work in the questions. Most of the long or structured question normally will start with the definition or stating the law. Like for instance, in question 2, if we're gonna ask you to state the law or to give the definition of any term, that is the first question that we'll ask. let's say for instance 2.1, it will be state Hooke's law or define strain. That is how the question will come. Grade 12s, if you have any question, you can WhatsApp that question on this number 060 667 5044. Let me repeat the number, the WhatsApp number. The WhatsApp number is 060 667 5044. That you can only WhatsApp us if you have any question concerning the topic, today's topic. Thank you very much, grade 12. Let's continue. The first definition that we'll get is what? Deforming force. What is deforming force? The question that you'll get, it will be define deforming force. Then what you need to say is deforming force is a force which changes the shape and the size of a body. That is how you answer the question. The question will be define the deforming force, and then your response must be deforming force is a force which changes the shape and the size of a body. And then we continue. For you to understand, we say when an external sufficient force is applied to a body, it causes the body to change the shape or the length or the volume. Like for instance, you see this bottle, I can apply a deforming force on this bottle. This bottle will do what? Will change the shape or the length or the volume. Like when you squeeze this bottle, you are changing what? The shape of the bottle, and it simultaneously you'll be changing what? The volume of the bottle. That is one of the examples that I can give. The deforming force can be detention force or compression force. You see, if we are dealing with a rope, that means when you stretch, when you apply a deforming force in a rope, that means it's the same as you are doing what? You are applying a tension on that rope, a tension force on that rope. Or compression, when you compress any body, like as I gave example with this bottle, if I compress this bottle, that means I'm applying what? Deforming force. What is a tension force? A tension force stretch the body. Like if I have a rubber band, when you stretch it out, you'll see that the length of the rubber will increase, and the shape of the rubber will do what? Will also change. That is what the tension is. And sometimes we don't see that there is a tension in the body, but there is a tension because sometimes the force that is applied or exerted on the object is very, very invisible. Okay, grade 12. The compression force. Compression force is when you compress the body. Is when you do what? You compress the body. Another definition that we'll be looking at is what? Restoring force. What is a restoring force? Or we'll ask you, define a restoring force. Then we say a restoring force is a force that is equal and opposite to the deforming force applied to a body. Is what? is a force that is equal and opposite to the deforming force applied to a body. That means when we talk about restoring force, that means you are undoing what the deforming force has done to the body. You are undoing it. You are undoing what the deforming force has done to the body. That is what restoring force is doing to the body. We say when a deforming force is applied to a body, the restoring force develops inside the body to oppose the effect of what? The deforming force, thus restoring its original size and shape of that body. Like when I squeeze this bottle here, I do what? I squeeze this bottle so that I can do what? I'm applying a deforming force. And then when I remove my hand, then restoring force will take place on this bottle so that the bottle can retain its normal shape and normal size. Elasticity. Define elasticity. We say elasticity is defined as the property of the body whereby the body regains its original shape and size when deforming force is what? Is removed. That means elasticity is the ability of the object, is what the object it has, or is what the body it has in it, so that it can do what? After the deforming force has acted on the body, then that property of the body is the one that makes the body to regain its shape and its size. Like I'm gonna give demonstration from a spring. We'll see here we have 3 springs. This is the original spring. That is how originally the spring looked like. After I've stretched the spring, I've pulled the string down here. Then you can see the string now is 2 times the original size or the original length. You can see here the string now, if I pull the string down, then the string will increase in size. And then when I leave the spring, that means the spring will go back to its original size and shape. Because of what? What makes this spring to be able to return to its normal size and shape is what we call what? Elasticity. Are we together, grade 12s? If you have any question, please feel free to WhatsApp the question to 060-667-5044. Okay, now we continue with saying example of deforming force and restoring force. We start originally with this spring. This is original spring with original size and original shape. Then deforming force took place on this spring here, and then it does what? The spring do what? Stretches out. Can you see, grade 12? Then what is going to happen is what? Restoring force. If I stop stretching pulling the spring down, or I remove the deforming force, then restoring force will now take place. And then to restore the spring to its original shape and size. Elasticity. We're still continuing with the definitions for elasticity. Now we're looking at what? Perfectly elastic body. We have materials or we have bodies that are perfectly elastic body. What is perfectly elastic body? Perfectly elastic body is a body which regains, this is very, very important, which regains its original shape and size completely when the deforming force is removed. We're saying the body, if this bottle is a perfectly elastic body, after I've squeezed it, then it will have ability to regain its original shape after I've stopped squeezing it, or after I've stopped applying deforming force. Like, this is an example of what a perfectly elastic body. At the beginning, the body looks like this, and then we do what? We apply a deforming force, and then what is happening? After then it changes the shape. Can you see the shape now? It's changed, and the size also has changed. But immediately when I release, I remove the deforming body, then this will go back to its original shape completely. Completely. Completely is what is very, very important also. We have another type of body which we call what? Perfectly plastic body. We say a perfectly plastic body is a body that does not show a tendency to regain its original shape and size when the deforming force is removed. Like, for instance, let's look at this. I'm interested in this. What is this? You know, that is a door that our grade 1s and grade R are using at school. If you have a door like this and you squeeze it, will it regain its normal shape or body? No, it won't. That is an example of what? Perfectly plastic body, because it doesn't show any tendency to regain its shape and its size. You can see here we have a plastic. This is a plastic. Can you see this hard plastic? This hard plastic, if you bend it, what will happen to it? It will broke. It will broke. Then will you be able, after you stop, after it broke, it will never go back to its original shape and size. That is what we call what? Perfectly plastic body. And I see this is a hood for us who like to bake. We're using this. What will happen if you apply a force on this wood? The wood also, it will, if you apply more force on it, it will break, but it will never regain its original shape and size. Can you see this is a toy knife here? A toy knife here. Also grade 12, a toy knife, what will happen if you apply a force on it? It will break, but it will never regain what? Its shape and size. Those are examples of what? Perfectly plastic body. As we said, that perfectly plastic body is a body that does not show any tendency to regain its original shape and size when the deforming force is removed. Even if you can stop, if I have a pen here, if I apply a deforming force on this, what will happen? It will regain its size and shape? No, because it is what? A perfectly plastic body. Elasticity, We continue with the definitions. Now we're looking at what? Elastic limit. Elastic limit. What is elastic limit? We say elastic limit is the maximum force that can be applied to the body so that the body regain its original form completely or remove on completely on removal of the force. Let's look this example here. We have this. This is the original spring. Now I do what? I apply a force downwards because this string, remember, is hanging on the ceiling. Then I apply a force downwards on this body. Then it will stretch to F, to this level. And then if I continue stretching it, then it will stretch again to this level. And then if I continue stretching it, then this spring, if I keep on stretching it, it will reach a point where this spring will not regain its original shape and size. Are we together? That means up to here, I can only stretch it up to here so that it does what? It can easily regain its shape and its size. That means the elastic limit is what? 2F. I can only apply a force that goes to 2F. If I increase my force there, then this spring might not regain its shape or size. But if I end here, then you can see now that spring is always going back to F and to its original shape and original size. Are we together, grade 12? There is a force where this force that I'm applying on the spring, there is a where it ends. That is where we talk about a limit. That's where it ends, so that this spring can regain its original size and original size and original shape. But if I continue pulling it, then it will reach a point where the spring will not go back to its original size or original shape. Okay, grade 12. Let's have an exercise for a 1 minute. You're gonna do it yourself. This is a multiple choice question. This is a multiple choice question. Just do it yourself for a 1 minute. Thank you, grade 12. We are back. Remember, grade 12, when you look at the structure of our question paper, that means For 150 marks, you are having what? 3 hours. Ne? That means time is very, very important. Okay, grade 12. Let's continue now. Let's do this together. Question 1. It says, a deforming force can change is it the size of the object only, the shape of the object only, the shape and size of the object only, the speed of the object, the speed at which the object moves? We can see that this is totally out. D is totally out. Then we're looking at what? The 3 options that we left. Then it's either going to be the size, the shape, or both the size and the shape. But according to the definition, we know that is C because it changes what? The shape and the size of the shape and the size of the object. Okay, let's go to the second one. Multiple choice again. As I said in the beginning, that the definitions are used in multiple choice questions. Can you see now? We're using them as I've said. It says here, number 2, which of the following statements about elasticity is true? Then we say, is it A, for a small deformation, object will return to its original shape when the force is removed? For a big deformation, object will return to its original shape when the force is removed. C, for all deformation, the object do not return to their original shape when the force is removed. Then D, it says, for all deformation, object return to their original shapes when the force is removed. Which one is the answer, grade 12, of elasticity? Which one is the answer for elasticity? We say D is the answer because we say for all deformations, object returns to their original shapes when the force is removed. The force that we're talking about here is what? Deforming force. Okay, grade 12s. Let's continue to number 3. It's still a multiple choice question. We say restoring force work in the same principle as restoring force. Which principle that we learned before? Is it a Newton's first law, A, or B, Newton's second law, or C, Newton's third law, or D, Newton's third law? Momentum. D is momentum. If you know the definition of this, all of this, then you'll be able to answer this multiple choice question. That is why it is very, very important, grade 12, to make sure that you know these definitions by heart. Meditate on them before you go to sleep every day, and then you'll know them by heart. The Newton's first law, we know that it says what? The object will continue moving on a straight line or uniform constant velocity unless an unbalanced force act on it. And the Newton's second law, it says what? It says When a net force exerts on an object, the object will do what? Will accelerate in the direction of the net force, whereby acceleration is directly proportional to the net force and acceleration is inversely proportional to the mass of the object. Then the Newton third law, it says when object A exerts a force on an object B, object B will do what? Will exert the same force but in the opposite direction to object A simultaneously. Can you see now? I exert a force on this bottle. Then what I'm doing, I'm applying a deforming force. Then restoring force will do what? Will act immediately when I remove my hand. Then the restoring force will do what? Will act on this to do what? To retain, to restore the shape of the bottle. Then momentum, we know, is what? Momentum is the product of the mass and the velocity of the object. Then which one is correct? Is it A or B or C or D? Then we say because there is what? Action reaction in Newton third law. We're taking it as what? The principle of restoring force is the same as what? As the Newton's third law. Okay, now we're coming to stress. Yes, this stress that we're talking about here is not the stress that you get when you are tired or you have problems. This is the stress that the material experience. It says, what is a stress? Define for us a stress. A stress, we say a stress is internal restoring force per unit area of the body. That means there is a force that I need to exert on this, and in taking in consideration the area of the body. That is why we're saying a stress is equals to what? Force exerted or applied on the surface. Like for instance, you see this bottle, if I apply a force on this side of the bottle, this, I know the area of the, I might know the area of the bottle, of the surface of this side of the bottle, then I'm able to do what? To calculate the stress, because the force that I'm exerting on the surface, I know the force, I know how much the force. Let's say for instance I apply 50 Newton here and I know the area, then I'll be able to calculate what? The stress. That is why we say stress is equals to the force applied on the surface of the body divided by what? The area on which the force is exerted. Are we together, grade 12? Then, mathematically, we say this is the formula to calculate what? Stress. And this formula, grade 12, we're not only using it to calculate the stress, we're also using it to calculate the area of the surface and the force that is applied on the surface. Let's go to the next slide. You can see this sigma, it stands for what? A stress. It stands for stress. And F is for what? Is for the force. And A is for the area. Remember this, we get this 3 from the formula. This is the stress, this is the force, this is the area. I have a problem here. Let me see if, oh, it's sorted. Okay, let's continue. We say the SI unit for stress is Pascal. Is what? Is Pascal. This Pascal is the same as what? Newton per meter squared. Why Newton? Oh, okay. We forget negative here. Is negative sign here? Ne? It's supposed to be Newton per meter squared. Ne? To show that this is, we divide by a area. This is the unit for area. Ne? Because to show that there is a division, we must have what? -2 there. Okay? And the formula for area, we know that the formula for area is what? Length times breadth, or length times width. Grade 12, that is the formula that we use to calculate the area. Why are we giving you this? In most cases, they're not going to give you the area of the surface. Then they just give you, let's say, the length and the width. Then you, before you calculate the stress, you need to do what? To calculate the area first. Are we together, grade 12? Yes. Then we say when dealing with the length, breadth, or the width, remember to do what? The conversions, because normally you'll get the same millimeter, the length and the breadth will be given in millimeter, or what, or centimeters. Then we know that the SI unit for length and breadth is what? Is meters. That means you need to convert this to meters, or centimeters to meters. You need to convert millimeters to meters, or centimeters to meters before you start to calculating the area of the surface. Okay, we have an example here. I'll want us to look at this example together. The example says, forces are applied. Let's read the statement together. Forces are applied at the rectangular block, which this is the rectangular block that they're talking about here, which is made of an elastic material. The block is made out of an elastic material. These forces are not applied to the block I can't see here. I can't see what is hidden by the block.
Believe in yourself. Believe a little more in yourself, because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing, because this can be done and you can be great.
Sorry, grade 12. Now we can say these forces are not applied to the block simultaneous. That means one force is exerted, and when this force is finished to exert, let's say for instance you apply a deforming force, then after you remove the deforming force, then the the restoring force then come to play. Then they say calculate the following. A, calculate the stress experienced by the surface at the top of the block when the force of 0.05 Newton 0.05 Newton. I'm having a problem here. Thank you very much, grade 12. Everything is in order for now. Technology, we know it always have its way of disappointing us. Okay, colleagues, grade 12, let's continue. We say forces are applied at the rectangular block which is made of a elastic material. These forces are not applied to the block simultaneously, as we said before. Then they ask us to calculate what the stress experienced by the surface at the top of the block when the force of 0.05 is applied at the surface. We're looking at the top of the block, and then we can see that the top of the block, the length is 6 centimeter and the breadth is 2 centimeters. Then B, it says calculate the force exerted at the side of the surface of the block if the side surface of the block form a square and experiences the same stress as the top of the surface. We have, if this is the block, we have the firstly A, what is happening? The force is exerted on the top, and now the force will be what? On B, we'll say the force is exerted on the side, like this side. Thank you. Then the solution. The first thing that we do, we know that the length is what? 6 centimeter, and the breadth is what? 2 centimeter. We need to do what? To do the conversion. We need to convert 2 centimeter into what? Meters, because the SI unit for the breadth and the length is in what? Is in meters. Then we take 2 centimeter, we divide by what? We divide by 100. We say 2 centimeter divided by 100 will give us 0.02 meters. Then the same applies to the length, which is what? 6 centimeter. We divide that 6 centimeter by 100 to give us what? It's going to be 0.06 meters, grade 12s. And then it's not 6 meters, but 0.06 meters. Okay? Then we are using what? The length first. Remember from the formula that says sigma is equals to F divided by A. We need to find out what is A, because we already know that the force is equals to 0.05 Newton. Then how much is the area? To get the area, we say what? Area is equals to length times width, which is 0.06 multiplied by what? 0.02, which gives us what? 0.0. It's supposed to be 0.0012. This is wrong. It's supposed to be 12. Are we together, grade 12? It's supposed to be 0.012. You can see here we have a correct answer. The answer for the area now is what? The area is 0.0012 meter squared. Then now, because we have our area, we can use our force that is given to calculate what? The stress. We say stress is equals to force divided by what? Divided by area. Then we're given that the force from previous slide, we're given that the force is what? 0.05 Newton. Then when we go here, we just take the 0.05, we put it there because it's our force, and we take the area that we calculated. This area here is the one that we put there. Can you see our grade 12? Then after we use our calculator, then we found that the stress is what? 41.67 Newton per meter squared. Per meters squared. This minus that you see here, we said is what it means per meter squared. Are we together, grade 12? Yes. Then we know that now the stress is equals to the stress that is the stress that the surface, the top surface of the block is experiencing is equals to what? 41.67 Newton per meter squared. If you have any question, please don't forget to do what? To WhatsApp that question to 060-667-5044. Let's continue, grade 12. Then to answer question B, we say also, we start. Let's go back to the question. The question says, calculate the force. Calculate what? The force exerted at the side surface of the block. If the side surface of the block forms what? A square. Forms what? A square, and experiences what? The same stress as the top of the surface. Okay. Now, here, you'll ask yourself, where do we get this 0.02, and this 0.02? Okay, firstly, they say what? They said the side of the block is what? It is a square. If the side it is a square, that means this side is 2 centimeter, and this side is what? 2 centimeter. Are we together? Because we're dealing with what? Square. In a square, all sides are equal. A square, all sides are equal. This side is equals to this side, is equals to this side, is equals to this side. That is why now we have what? This side is 2 centimeter, this side will be 2 centimeter, and this side will be 2 centimeter, and this side will be 2 centimeter. That is why now when we convert this 2 centimeter into meters, that's when we get what? 0.02. We get what? 0.02. Then is 0.02 of this side and 0.02 of this side. And that gives us what? The area. When we multiply the 0.02 from this side and 0.02 from this side. Then we're calculating what? It will be the same as we're calculating what? The area. Then we found that when we say 0.02 multiplied by 0.02, it gives us what? 0.0004 meter squared. Remember, the unit for area is what? Is meter squared. Don't forget to put the units. SI units are very, very important, because if you don't put SI units at the end of each and every calculation, you lose that mark, the final mark. You lose it, grade 12s. Okay, now let's continue. We're saying now, we managed to get what? We managed to get the area. At this instant, we are calculating what? We are not calculating stress, my grade 12s. We are calculating what? We are calculating the force. And then when we go back to the question, they say the same stress. The question says the same stress that the side of the block is experiencing is the same stress as the top of the block is experiencing. That means, that is why here, when we substitute, we say, when we substitute, we say what? We say the stress. We start substituting the stress. Where do we get this stress? Let's go back we get the stress from A. Remember, when you're calculating the stress of the top of the block. A, we calculate the stress of the top of the block. We found that the stress is what? 41.67 Newton meter per second squared. Then we are using the same value of stress to calculate the force that will be applied on the side of the block. We're using the same stress because the question itself, let's go back to the question. The question itself, it says here, let's look here. It says the force exerted at the site, it says calculate the force exerted at the site surface of the block. If the site surface of the block is what? Form a square, and experiences, the side of the block does what? Experiences what? The same stress as the top of the surface. That means the stress that this side of the block is the same as the stress at the top. Are we together? That is why that qualifies us to use what? This value of the stress of the top to calculate what? The force. Are we together? We can now, as we substitute, you're asking yourself, where does this 41.67 comes from? Okay, my grade 12, it comes from the value of stress from A, from the last slide. Then we substitute the stress, and then because we are calculating for the force, we can't substitute the force because we are looking for it. Then we substitute what? The area. Remember, this area here is this area here that we calculated above. Then remember, grade 12, when we mark this kind of calculation, you first get 1 mark for writing down the formula correctly. Are we together? And then you will be what? Get a mark for correct substitution. 2 marks for correct substitution. And the last final mark will be for what? For the final answer. Are we together? Then, when we look here, we say now we substituted the stress and we substitute what? The area. Then, after we did that, then we can do what? We can make the subject of F, the force, the subject of the formula. Then when we make the subject of the formula, how do we make the F the subject of the formula? We say we just multiply both sides by 0.004. Like we say 41.67 is equals to F divided by 0.0004. Then we multiply by 0.0004 this side and multiply by 0.0004 this side. Remember, what you do on the left, you must also do on the right. We multiply both sides by what? 0.0004 both sides. Then this 0.004 will cancel this one. Then we left with this side on the right, we left with F. And then this what you see here is this here. Can you see? 41.67 multiplied by 0.004, which is gonna be equals to, when we multiply 41.67 times 0.0004, it gives us what? 0.0167 Newton. And in most cases, they will say you must write what? 2 digits after the comma. Are we together? Then if they say 2 digits after the comma, then it's going to be what? 0.02 Newton. Can you see my grade 12? Yes. If they ask you to write the final answer into 2 digits, then into 2 decimal places, then you know that it's going to be what? 0.02 Newton. Okay, let's continue. We're looking into a strain. If you have any question, please don't forget to do what? To WhatsApp your question, so that we have a technical team that is responsible to answer all the questions immediately. Strain. Definition for strain. If they ask you to define the strain, then this is what you must say. You must write. It says strain is the ratio of change in dimension to the original dimension. What does that mean? Is the ratio of change in dimension to the original dimension. That means strain is when I have this and stretch it, this will increase by a certain length. When I take the length that this has been stretched with, and then I divide with the original length, that it gives me a strain. I stretch this, let's say I stretch this from here to here, then I take this distance that I've stretched the material or the body with, and I divide that distance with the original. I take that length, I divide by original length. Then that gives me what? A strain. That is why we're saying to calculate the strain, you must say change in length. Change in length is what I've stretched the body, the length that I got when I stretch the body, divided by what? The original length, which is the length of the body. Are we together? Then mathematically we say, this is mathematically, is what? Change in L divided by capital letter L. And then what does that mean? This stands for what? This stands for what? A strain. And this means what? Remember the triangle. When you see triangle every time in the calculation, you must know it means change. It stands for what? Change. That is why we have what? Change in length. L here, this small l is what? Is length. It shows that we are moving length from say one point to another. Is a change. Then the capital letter L is what? It stands for original length. It stands for what? Original length. Then we say strain does not have a unit. Unlike a stress. We know stress is what? The SI unit for stress is what? Is Pascal or Newton per square meter. Is what? Pascal or Newton per square meter. Then the strain doesn't have any unit. Why? Because the unit, they cancel each other. The unit for changing length is what? Is the same as the unit for original length. Then they cancel. They are both what? Meters. Then it's going to be meters divided by meters. Then they cancel each other. That is why we don't have what? We don't have any unit for strain. Okay, grade 12. We have example for strain. I'm going to ask to do, let's do this together. Let's do this together. It says, a rod has a diameter of 50 millimeters. Let me underline this so that as a given data, we have 50 millimeters. What is a diameter? Diameter is the length from the bottom of the circle, from the bottom to the top, from one end to the other end of a circle. That is a diameter. And if the circle has a center, if a circle has a center like this one here, from here to here, from the center to the circumference, we call it what? A radius. A diameter is radius plus a radius. Can you see? A radius is what? Circumference. This is a circumference. It's a circumference, and then this is the center. Diameter is from a circumference at the top to the bottom. A point from the top to the bottom. That is a diameter. And if you want a radius, you move from where? You move from the circumference from the top, you go to the center. That is a radius. And that means a diameter is what? Is equals to 2 radius. When you add 2 radius, that means you'll get what? A diameter. Are we together, grade 12? When you add 2 radius, you get what? A 1 diameter. Or if they've given you a diameter, that means to get a radius from the diameter, you need to divide that diameter by 2 to get what? A radius. If you have a diameter and you need what? You need a radius. That means you need to divide the diameter by 2. Then you'll get what? A radius. Okay, let's continue. The length of the bar is what? 5 meters. Are we together? That means initially, before this bar was stretched, it ended here. Can you see? It ended here initially. Then now, what is happening is what? It is stretched with a force of what? 10 kilonewtons. And it extended by what? 0.1 millimeter. That means when we stretch it to what? With a 0.1 millimeter. At the beginning, originally it was here, the length it was here, then this is the length that we stretched. That means this will be what? Change in L. Can you see? This will be change in L, and this will be capital letter L. Can you see? Grade 12? Yes. Then we continue. The question says, calculate the following. Calculate the stress experienced by the rod. Okay? Then, secondly, they say, calculate the strain experienced by the rod. Remember, in order to calculate the stress, we need what? We need force and we need what? Area. Because stress is equals to force divided by what? By area. Then, to calculate the strain, we say the strain is equals to what? Change in length divided by original length. Or divided by original length. Okay, let's continue. A, they said we should calculate what? We should calculate the stress. Yes. Then, let's calculate the stress. First, we do what? We do some conversions. The force that we're given is 10 Newton. Then we need to convert that because the force, the SI unit for force is what? Is a Newton. Can you see? Then we need to convert kilonewton into Newton. We need to do what? To convert kilonewton into newtons. And kilo, well, always when you see kilo, you must know that it means 1,000. Kilo, it means 1,000 in physical science. In technical science, in technical science, we say kilo, it means 1,000. That is why now we have what? At the beginning we had what? 10 kilonewton. Then now we're having what? 10,000. Can you see? We have what? 10,000 newtons. Are we together? That is how we convert. We multiply that 10 by what? By 1,000. Then it gives us what? It gives us 10,000 newtons. The radius. Now we need to calculate what? The radius. We said the radius is what? Diameter divided by what? 2. That is why here the diameter it was given to us as what? 50 millimeter. Then we divide that by 2 to get what? 25 millimeters. But millimeter is not the SI unit for what? For length or for radius. Is what? The SI unit is what? Is meters. That means we need to do what? To change this 25 millimeter into meters. Then we divide by what? We divide by 1,000. Remember, where if you have millimeters and you want to change it to meters, you divide by what? You divide by 1,000. If you have a centimeter and you want to change it to meters, you divide by what? You divide by 100. Are we together, grade 12? Yes, that's how we do our conversions. Now we say the area. Can you see the area of a circle? Because now we're dealing with a circle. We're no longer dealing with a block. If it was a block, remember the block, they said, when dealing with the block, they said the area is what? Is the surface is a square. Ne? And when you calculate the area of a square, we say area is equals to length times width, or length times length, or length times breadth. Are we together, grade 12? Now we're dealing with a circle. This is the formula that we use to calculate an area of a circle. That is why it was very, very important for us to get R. This R that you see here, it stands for what? Radius. And then you're asking yourself, what is this that looks like a bench? It's not a bench, it's what we call a pi. And then on your calculator, you have it, and then we say pi is equals to 3.14. Are we together? Pi is equals to what? 3.14. Then, grade 12, when we substitute on the formula of an area, we substitute the pi as what? 3.14, as I mentioned that pi is equals to 3.14. Then we multiply by what? Radius. This is what? The radius. Remember, this comes from here. The radius. Are we together? The radius is 0.025. Then because this squared, radius here is being squared, then even here we're gonna square it. Are we together? We're gonna square 0.025 because of this here square here, in order to get what? Our area. And then thereafter you can use your calculator to get this. You just say 0.025 square is the same as 0.025 times 0.025, and then you multiply by 3.14. Then the answer when you use a calculator, it will be 0.00196 meter squared. Are we together? Because it's an area, it must always have what? The unit of what? Meter squared. Then to calculate the stress, we know we said what? The force is this one. We've just substituted here. And then the area is this one here. We put it here. Can you see? We substitute here. Next, grade 12. Then when you say 10,000 divided by 0.00196, you get what? 5,095,541,4 Newton per meter squared. Are we together? Or you can write this in a significant order, where you say what? We move comma to the right. You see where comma is? We move to the right. Then we say 1, 2, 3, 4, 5, 6. Then we put comma in front of 5. Then we say, we write everything else. We put comma there. Then we say times 10 to the exponent 6. Then that's how you can write. If you don't want to write it like this, you can write it like this. Or in short, you can say is equals to 5,1 Newton meter per second squared. Remember per second, we forget a minus here also. Put minus there in front of the 2. Then B, they say what? Calculate the elasticity of what? Calculate the strain. So they calculate the strain. Then the strain we said, can you see here? We were given 0.1 millimeter. In order to change it into meters, we do what? We divide it by 1,000. Then we get what? 0.0001. And then this 5 here, remember, is the 5 that was given here, is this 5 here. Then the original length is the original length. Then when we divide 0.001 divided by 5, it gives us this. Are we together? It gives us 0.00002. Because we don't want to write long 2's, lots of 2's, then we say what? The answer here is going to be 2 times 10 to the exponent negative 5. Sorry, we forget negative here also, is negative 5. Remember we said strain does not have any unit. Are we together? Strain does not have any unit. And it's important to do what? To do your conversion before you start. You start by doing what? You start substituting. Are we together, grade 12? Then you can see here we took 0.1 millimeters. We changed to 0.000 1 meter. Are we together? Then when we do that, this is the length for doing what? The length that the material have been stretched. We said we have this. Then if we stretch it up to here. Then this piece that we stretched with is this length. And then this 5 is the original length of the body or of the rod. Are we together, grade 12? Then grade 12, this is the homework. We know that we can't just end the lesson without giving you a homework. This is a homework for today, and then please use it to practice. The homework we say, number 1, we say, define the following terms. Define the following terms. Define elasticity. Define perfectly plastic body. That is B. And C, we say, define elastic limit. Please, this will help you to practice the definitions. Then, number 2, we say, it's a calculation problem. We say, a force of 60 Newton is applied to a cylindrical rod of 20 millimeter radius. Calculate the area. Calculate what? The area. And then B, we say, calculate the stress experienced by the rod. Calculate what? The stress experienced by the rod. I'm going to start with number 1 to explain number 1. Remember, in number 1 is only definitions. You need, grade 12, when you did this homework, please don't copy. Study these definitions so that when you do the homework, you just write definitions from your heart because you'll be knowing them. Are we together, grade 12? Then you'll be easily write them, and then please mark yourself if when you finished to see that you know these definitions by heart. You know them. And if you can get them correct now, you'll even get them correct when you're writing the prelim and when you're writing the final exam, grade 12. Then let's go to number 2. In number 2, the first thing that you need to do is to do what? Conversions. Convert the radius into the correct SI unit. Are we together, grade 12s? Conversions is important. Start with conversions. And then also, remember, this is what? Is a cylinder. How does the cylinder look like? The cylinder on the side is a circle, and then it's like this. Can you see? A cylinder looks like this. That means the area that you must calculate is the area of the circle. Are we together? The area of a circle. That's when you'll be able to calculate what? The area. I'm just giving you guidance, and then you remember the formula of the area of a circle. Are we together? It is what? Area is equals to pi r squared. Is what? Pi r squared. Don't forget it. Don't forget it. It is very, very important. And grade 12, learn different areas. Are we together? Learn different areas. Like for instance, area of a square is equals to length multiplied by length. Area of rectangle is equals to what? Length times breadth. Are we together? Then area of what? Area of a circle is what? Pi r squared. Can you see? This is for what? Square. This is for what? Rectangle. And this is for what? Circle. Are we together? You know that even if you come across any type of question that wants you to calculate area, you know that you look at what is the shape of that area, of that surface. Then we know that it is very, very easy for you to be able to calculate the area. Then B, they say, calculate what? Calculate the stress experienced by the rod. You know the formula here? I know you know the formula. Then the formula is what? Is stress is equals to force divided by what? By acceleration. Then you are able to do what? To firstly, you will use this area that you must use here is the area that you calculated in A. And then the force will be the force that is given, which is what? 60 newtons. Then grade 12s, you'll be able to do your homework. And I'm sure that you'll be able to get this homework, all of it correct. And if you have a question, don't forget, the number is what? 060-667-5044. Are we together, grade 12s? Forward your question. We have a team that is ready for your question. We have a team that is ready for your question. Don't be shy. Just SMS, just send us question. Are we together? Yes. Then thank you, grade 12s, this is the end of today's lesson. Please remember the COVID-19 protocols. Wear your mask. Here is my mask. Sanitize and still keep social distancing. COVID is still with us. Thank you very much.